Hi, welcome to the Advanced Manufacturing Lab. My name is Rick Osbrink. I'm a machining instructor here at the college. So today we're going to talk a little bit about edge finding. In manufacturing, a lot of times we have to accurately locate our tool over top of a workpiece, or in CNC machining, we have to locate our part within the piece of equipment. There's many options when it comes to finding a location on a part. One option, if we're using a CNC machine, is something like this Renishaw probe. But this is a pretty pricey probe. This is about a $3,000 setup. And this Heimer is a good one that speeds up the process. It'll do exactly the same thing that our edge finder will do, and then a little bit. But again, this is a pretty pricey little probe. The one that we're going to be using today is this old traditional edge finder. So this edge finder is 3 individual components. Here's one that's broken apart here that we can look at. There's a body right here that's hollow. Inside that body we have a spring, and then attached to the spring is the tip on the end here. That allows that tip to move around freely, and this is what we're going to use in order to determine the edge of our part with this setup right here. So this is the precision ground tip on the top of the edge finder, and there's the shaft up here that's held inside of a R8 collet. So initially how this works is we're going to take this tip and we're going to push it off of center. I'm going to start up the machine, and that tip is going to be very off center. It's going to wobble. I'm going to bring that tip up alongside the edge of my workpiece, and I'm going to pay really close attention and watch it. What's going to happen is it's going to get more and more concentric with the body, or in line with the body. It's going to go all the way until it hits a point where there's just enough pressure on the side of the workpiece that the tip is going to hop off to the side. At that point, we know that the edge of our edge finder is directly on the side of our workpiece. Let's look and see how that works. So I'm going to start the piece of equipment up. We're going to bring it down below the surface, and I'm going to slowly bring the edge finder over to my workpiece. Once it starts to get concentric, I'm going to do really slow advancement on the table until we watch that edge finder hop off. It's going to hop towards the back. And there we go. So at this point, the side of our edge finder is directly on the edge of a part. So I can go over to my dial and I can set it to 0. Or if I have a digital readout, I can set that to 0 as well. Now, a lot of times what I like to do is I like to move off the workpiece and do it again just to make sure that I've gotten the right reading. So let's try that one more time. We're going to start it up, bring it into our workpiece, nice and slowly until it just hops off. Perfect. So it's about 6 to 8 10,000ths of an inch that we're off from our first. Now, we have a good established location on the edge of our part, but we have to do a little math at this point. So essentially, our edge finder is pushed up against the side of the part. Now we want to be able to measure off of the edge of our part right here, but we have the whole diameter of our edge finder. So we need to take that diameter into consideration. Remember, I talked about the fact that this is a precision ground piece of material. So we know that this is exactly 200,000ths of an inch, or 2/10. That's 0.200 of an inch. So what we have to do is we have to add the radius, or half the diameter, to our measurement in order to get the center line of the spindle over the edge of our part. Once we've done that, then we can progress whatever distance in this direction that we want to, say an inch or so, to get our tool positioned directly over that spot in the part. And then we can follow the same process working on another reference point of the part to bring that up and get located exactly where we want to. Usually this is accurate within a thou or two, or 0.001 of an inch. We can be accurate to our whole position with this type of technique. Again, my name is Rick Osbrink, and if any of this interests you, we have an amazing program here at Shasta College that'll teach you all about the manual and CNC pieces of equipment that we have here. So contact your counselors today and get enrolled. We'll see you soon.